Hello everybody, my name is Paul Schwarzbach. I work at the Institute of Traffic Telematics at Technische Universität Dresden. And in this short little video, I would like to give you guys an overview for our contribution for the International Conference on Localization in GNSS, where we present a novel approach on how to tightly incorporate GNSS pseudo-range measurements with locally available ranging measurements based on spatial map data to enhance localization in urban environments.
We achieve this by applying a non-parametric state estimation based on predefined discrete position candidates. This also allows the application of different measurement models, which can also be non-Gaussian, for different technologies. So we do not rely on the Gaussian assumption, and we can also incorporate single ranges coming from different systems. The proposed probability grid positioning essentially is a multidimensional histogram filter, which is a type of discrete Bayes filter following a classical prediction and observation structure. In the prediction step, we calculate translational probabilities for all grid points depending on movement assumption or even movement measurements, for example, the pose of the vehicle. In the observation step, we translate our ranging measurements in a likelihood representation using the predefined grid points and an associated error measurement model, which doesn't necessarily have to be Gaussian. So this is a huge advantage of this approach. However, for global positioning problems, discrete state space initialization can be tricky and computationally heavy. For this purpose, we use digital elevation models, which are a discrete 3D representation of the Earth's surface, and perform a intersection with a road map network to create a resulting state space for vehicular navigation problems. Using this representation then allows us to also incorporate non-Gaussian measurement models, which are typically degrading positioning performance for approaches like the least square estimation or the extended Kalman filter. In our paper, we also present a modeling and simulation approach for both GNSS pseudoranges and locally available ranging measurements, given certain error types and associated occurrence probabilities depending on different environments as well as different technologies that can be used. For the case we are discussing, the both resulting error distributions are shown in the left side, clearly revealing a heavy-tailed distribution. And in the right side, we can see some qualitative results revealing very little positional outliers, even in the presence of potential non-line of sight and multipath reception. More results as well as details on the implementation and the error modeling can be found in the paper, which will soon be available at IEEE Explore. Thank you very much for tuning in. I hope you enjoyed this video. See you soon.